This presentation will focus on UCERT Tool 2, named the User Building Operational Rating Solution, which is part of a set of tools to be developed under the UCERT project Work Package 5 that ISO is leading. It consists of a series of tools that enrich the UCERT Energy Performance Certificate with additional information that will be displayed on it and that help make UCERT Energy Performance Certification more reliable and understandable, even for non-expert users.
The content of this presentation has been prepared by Niccolò Mignani, civil engineer working at ISO in the Netherlands.
UCERT Tool 2 has been designed to be a cloud-based service accessible through any web browser with a user account, enabling an evidence-based decision-making process. The idea behind UCERT Tool 2 is to rely on several supporting tools, covering a wide range of topics which were spreadsheets initially developed in other projects and which have been translated into digital tools to support the UCERT Energy Performance Certificate. These supporting tools are going to be presented in the next slides. I will start with the Aldentail. It is within the scope of UCERT as measured assessment, and it is focused to cover indoor environmental quality indicators. So, the tool covers elements from temperature, acoustic, indoor air quality, and lighting. It is flexible to not having information on all elements, although measurements are needed at least for one of the elements to be assessed. Otherwise, the tool cannot provide any measurement-free assessment. So, for instance, if measurements are available only on the temperature element, it is fine. It means that that part of the whole assessment can be assessed. In the end, what is obtained as output data is a general detail index, which would be a building covering the thermal environment, acoustic environment, indoor air quality, and lighting, an overall indicator for the whole building indoor environmental quality. So there will be 5 indicators. One detail index for the whole building, and then one indicator for thermal environment, for acoustic environment, indoor air quality, and lighting environment, if all the things manage to be assessed within the tool. The current situation is that the 3 Aldentail spreadsheets related to dwellings, hotels, and offices are being translated into web tools by Flexility and will be ready soon. Sensi tool is a translation of standard EN 15378-3, which deals with measure energy performance, covering the heating and domestic hot water services, and it has been developed in the framework of the Sensi project. This tool is within the scope of UCERT operation assessment and actually just focus on heating because there is a current limitation in terms of EPB standards available. This tool is the resource that helps us bringing the gap between as measured assessment and operational assessment, going from as measured values to standardized and normalized values, which can serve for building comparison. For the scope of this tool, measurements are needed, and measurements understood as information like energy invoices, meter readings, maintenance report, and on-site monitoring by building automation and control system, building maintenance system, and then like. This tool allows for 2 different methods, the energy signature method and the seasonal data interpolation, which are very similar, although there is a small variation on the input data. However, the energy signature method has been the one translated into digital tool. As output, what is obtained is the delivered energy for heating and also an additional value which is the estimated indoor temperature. The Sensi spreadsheet related to the energy signature method is being translated into web tool by Flexility and will be ready soon.
The Smart Readiness Indicator is leveraging UCERT, and it's actually one very important element of UCERT methodology and value proposition, and belongs to the scope of UCERT operational assessment. The tool covers heating service, domestic hot water service, cooling service, controlled ventilation, lighting, shading elements or dynamic envelope, electricity generation, and also it considers electric vehicles. It allows for two different methods. Method A, which is a simplified method that contains a list of selected services, and Method B, the detailed method covering all services. Moreover, to carry out the tool, measurements are not needed. So, welcome to the SRI web tool. The tool starts with an introduction to the tool itself. Then we have some mandatory information that must be filled in, as I've already done in this case for the assessor information. Some of them are related to our own knowledge about the building we are assessing. So this is a residential building. In this case, for example, we have a residential building, a single family house located in Italy with a total useful floor area less than 200 square meters, and so on. Then the methodology that we want to use must be chosen and the assessment date must be compiled. Now we can step to all the domains covered by the tool, which are heating, domestic hot water, cooling, ventilation, lighting, dynamic building envelope, electricity, electric vehicle charging, and monitoring and control. Let's start with the heating domain. First of all, we have to select if the domain is absent and not mandatory for our assessment, if it is present, or if it is not present but mandatory for the assessment. Let's select that the heating domain is actually present in our building in this case. Then, for each domain that is actually present in the building, there are several elements which depend also on the method previously selected. So for method A, the elements which belonging to the heating domain and that must be assessed are the heat emission control, the storage and shifting of thermal energy, the heat generator control, all except heat pumps, the heat generator control just for heat pumps, and the report information regarding heating system performance. Let's start with heat emission control that we will take as an example. If it is present, then we have to select the level of functionalities from a list of possibilities, ranging from level 0, no automatic control in this case, to a maximum of level 4. That is, in this case, means individual room control with communication and occupancy detection. Let's select level 3, individual room control with communication between controllers and to building automation control system. If the share of the functionality level is less than 100%, please provide the functionality level that applies to the remaining surface area, always selecting from a list of possibilities. So this is just an example of what different functionality levels may look like for each element within each domain, and this would be in relation to the SRI calculation. So once the building information and all the domains are filled in, then the output data are obtained. The main one is the total SRI score, which is immediately obtained and which provide how smart ready the building is. We also have other partial output data such as the impact scores in terms of energy efficiency, energy flexibility and storage, comfort, convenience, health, well-being and accessibility, maintenance and fault prediction, and information to occupants. and also some domain scores for each of the specific domains and services that I presented before. There is also an impact about how smart ready each of these sections is. So that is very valuable also to take some renovation actions in terms of increasing digitalization and connectivity of buildings. So, up to now, all the tools from other projects and or research initiatives and their current status within the UCERT project have been explained. This is everything from my end. Thank you for your attention and feel free to follow up on the results of UCERT project through the website and through other communication channels.